In this video, we are going to see that which kind of the functions are said to be continuous and also the differentiable. So we all know that the function is continuous when the limit exists, the function is defined, and the limit of the function is equal to the function itself at that point exactly. But how can we find out that the function is differentiable or not? The function is differentiable if and only if it is continuous. So the first condition of the differentiability is the continuity. Means if the function is not continuous, it means there is no point that it would be differentiable at that point. But if the function is continuous, it doesn't mean that it would be differentiable by all means, which means that differentiability implies on the continuity, but the continuity doesn't implies on the differentiability. So for differentiability, the condition is that the function has to be continuous. Whereas if the function is continuous, so maybe it would be differentiable and maybe not. Now, if the function is differentiable, then there is no point that it was discontinuous, which means that the differentiable function is continuous. So, with the help of the graph, when would you see that the function is continuous and or not continuous? So, you can see this graph which is in front of you. In this graph, there is no gap, there is no discontinuity, there are no broken lines. If you see from here and the graph is going on and on, it is in the open interval. It is the open interval because the graph is not ending. Or even if it is a closed interval, you can see that between the closed intervals, you can't see any kind of the gap or any discontinuity. So you can easily say that the function is continuous. Now the question comes that looking at the graph, if the function is differentiable or not. So whenever you see the smooth curve, you can see that the curve is just like a snake. It is moving like the snake. It is a very smooth, right? So if you see the smooth curves, so you can conclude that yes, they are differentiable functions. So this is how, looking at the graph, you can say that the function is continuous or not continuous or differentiable or not differentiable. For the continuity, I have made already one video in the limit section. So you can see that video to understand the concept of the continuity. But right now for the differentiability, understand that the smooth curves shows you that they are differentiable. Now have a look at the first graph. In the first graph, you can see that at this point, at point A, there is a cusp or corner. So whenever you have the cusp or corner at this point A, you can say that it is not differentiable at x equals to A, which means you can see that the function is continuous, right? There is no gap, but the function is not differentiable. Why it is not differentiable? The reason is that it has a corner or the cusp at x equals to A. Now, second question. Here in the graph number B or graph number 2, you can see that the lines are broken. So if the lines are broken, you can say that the function is discontinuous or not continuous. So if the function is discontinuous, there is no point that it would be differentiable. So you can say that it is not continuous at x equals to A, and the name of the discontinuity is jump discontinuity, because the discontinuity of the broken lines is named as the jump discontinuity. Now have a look on the third graph. In the third graph, you can see that the graph, although it has a smooth curve, okay, it seems to be a smooth curve, but it is not in actual a smooth curve, but it is continuous, number one. But you can see on the A, if I make the tangent line, so it gives me the slope of the tangent line is undefined. So you can say that the slope of tangent line is undefined. Tangent line is undefined. And slope of tangent line means what? Derivative. So the derivative is undefined. So if the derivative is undefined, so how could the function would be? So you can say that the function is not differentiable. The function is not differentiable. Where? At x equals to a. So it is important for a function to be continuous that it has the smooth curve where the slope is defined or 0. But if in any of the curve you find the tangent line and the slope of the tangent line undefined, which means that the derivative is undefined, and since the derivative is undefined, you can conclude that the function is not differentiable. Similarly, whenever you see any corner or the sharp turn, you can say that the function is not differentiable. Now, analyze the first graph. What have you seen in the first graph? In the first graph, you can say that the function is continuous, but the function is not differentiable. And where it is not differentiable? At x equals to a. Why? Because of the sharp turn. In graph number 2, you can say that the function is continuous, but the function is not differentiable. Why? Because at x equals to a, the slope of the tangent line is undefined. Because the slope of tangent line is undefined. So that's why the function is not differentiable. In graph number 3, you can see that in the graph there is a sharp turn. It is actually the graph of an absolute value. We know that these V-shaped graphs are the absolute value functions. And we also know that the limit of the function, that the derivative of the function from the right hand side and from the left hand side, they are not equals. So that is the reason of the not differentiability mathematically. So it is continuous, yes, but it is not differentiable. The first reason is that it has a that the curve is not the curve is not smooth. It has a sharp turning, and the second reason is that the limit that the derivative from the left hand side and the right hand side are not equal. Now in the next graph, graph number 4, you can see that the function is continuous but not differentiable. The reason is that it also has the sharp turn. And not only the sharp turn, you can see if you want to make over here the tangent line, okay, over here you will see that the slope of the tangent line is undefined. So here at this point, the slope is undefined. So the points of non-differentiability or discontinuity must be defined also to clear all the concepts. So here not differentiable at x equals to a. Now how can we solve or how can we understand about the continuity and differentiability looking at the piecewise function? So we know that in order to understand about the differentiability, it is very important to understand to do the test of continuity. So the continuity test or discussion about the continuity is very necessary. So we all know that how can we solve these things? We will find the limit from the left hand side and the right hand side at 0, because these are the conditions of the continuity or differentiability. So limit x approaches to 0 from the left side, limit x approaches to 0 from the right side, limit x approaches to 0 from both sides, and limit n f of 0. We have to understand 0 from the left side means when x is less than 0. So we will choose the equation as minus 9x minus 6. 0 for the right side means x is greater than 0. So my second equation, that is x square minus 9x minus 6. 0 from both sides, we write the function because it's answered based on the right and the left side limits. F of 0 where we have the equal sign, and you can see in the second equation I can see very clearly this equal sign. So I will choose my second equation. Let's check about the continuity. Apply the limit. In place of x, write down the 0. We will see it's equals to negative 6. In the second equation, when I write here 0 square minus 9 times 0 equals to negative 6. So again, it is also equals to negative 6. And the next question, since both of them are negative 6, so my limit from the both side is also negative 6. If I apply here the 0, also I will get negative 6. So it means, in short, my function is continuous everywhere. Okay, so I can write limit x approaches to 0 from the left side is equals to the limit x approaches to 0 from the right hand side, and limit x approaches to 0 from both sides is equals to the function itself at 0. Which means conclusion is that the function is continuous. Now, if the function is continuous, then of course I am ready to do the test of differentiability. Now, how can we use the differentiability test? So very easy. In order to understand about the differentiability test, you take the derivative, yani write the limit x approaches to 0 from the right side, limit x approaches to 0 from the right side. But here, take the function's derivative, means minus 9x minus 6 prime. Similarly here, take the derivative of the function from the right hand side. Okay, take the derivative. So the derivative, you will get limit x approaches to 0 from the left side. The derivative is minus 9. And from the right side, the derivative is 2x minus 9. Now apply the limit. So the limit, after applying the limit, there is no x, so I will get the minus 9. If I apply here the limit, so 2 times 0 minus 9, I get minus 9. So you can see that the derivative from the left side and right side are also equal. So limit x approaches to 0 from the left side derivatives is equals to the limit when I find out the derivative from the right side. They both are equal, which means I can say that the function is differentiable. Practice one more example. So the first of all, we will do the test of continuity. So take limit x approaches to 0 from left side, from the right side, from the both side, and f of 0. So from the left side means x is less than 0, so it means the first equation. Right side means x is greater than 0, that means 2x. From both sides, we always write f of x. F of 0 means equal sign. So you can see that on the first equation, there is the equal sign. So we will take the first equation. Apply the limit, we get the 0. Apply the limit, we get 0, which means that the limit exists. And apply the limit, we get 0. So we can say here that limit x approaches to 0 from the left side is equals to the limit x approaches to 0 from the right side. Furthermore, limit x approaches to 0 from the both side is equals to f of 0. Now the function is what? Function is continuous. So I am ready to understand or to discuss my differentiability. And you know that how can we find out the differentiability and how do we discuss the differentiability? By taking the limit, taking the derivative from the left side and also discussing the derivative from the right side. So left side is x square with the prime and right side with 2x with the prime. So if I take the derivative of the function which is describing from the left side, it will be 2x. And from the right side, this answer is 2. Derivative of 2x is 2. If I apply the limit, I will get 0. And in the second one, the answer is 2. So you can see that the left hand side derivative is not equals to the right hand side derivative, which means that the function is not differentiable. So this is how we understand about the differentiability or continuity together. So the only difference is that in continuity we write the function itself, and in differentiability we write the derivative of the function and then we apply the limit. And based on that one we agree that whether it is differentiable or not. Let's take one more example, limit x approach. Let's see one more example to make more things clear. So for example, this is 2x plus 1 and it is 4x minus 1. X is greater than 3 and x is less than and equals to 3. Okay, so let's suppose these are the functions which are given to me and I have to find the differentiability and continuity at 3. So first I will do the continuity test, and for that reason I will write limit x approaches to 3 from the left side, from the right side, limit from the both sides, and then I have f of 3. So for the left side you can see I will take my below equation. The reason is this is here x is less than 3. So you see that not all the times the less than equation is written on the top and the right hand side equation is written at the below side. You have to look very precisely the conditions which are given over here. So left hand side means x is less than 3, so which is 4x minus 1. Right hand side x is greater than 3, that is 2x plus 1. Apply the limit. So 4 times 3 minus 1 gives me 11. Similarly here apply the limit in the second equation. So 2 times 3 plus 1 it gives me 7. So are they equal? No, they are not equal. So which means the limit does not exist. Now the continuity at 3 exactly. So I will choose my second equation because here is the only one where they are saying less than and equal to. So 4x minus 1, apply the limit, you will get 12 minus 1, yani 4 times 3 minus 1. So I will get 11. So here you can see that limit x approaches to 3 from the left side is not equals to limit x approaches to 3 from the right side. Furthermore, limit x approaches to 3 from both sides is not equals to the function itself at 3, which means my function is not continuous. Now, if the function is not continuous, no need to do the differentiability test. 100% the differentiability test will not be fulfilled. So just write here, not differentiable. That is my complete answer. So I hope that you understood the concept to understand about the continuity and the differentiability test. Thank you so much.